Hello, we're here today with Chin Kai Meng, known as Kai, a senior applications scientist at Agilent Technologies, who's going to take us through the standard operating procedure for catchers using Agilent Samplique's catcher's kits. Can you start off by talking a bit about the advantages of the catcher's method?
Hi, yes, of course. Pesticide residue analysis of food and environmental samples have been performed for more than 40 years. Food safety analysts must perform multi-class, multi-residue methods to detect many pesticides, hundreds potentially, in a sample. Plus, there is a wide range of chemical properties of pesticides, including acidic, basic, and neutral, and a wide variety of matrices, polar, nonpolar, fatty, waxy, etc. What's great about catchers is that it is a simple and quick method and only involves a few steps. Yet, it prepares the sample for identification of multiple pesticides. Whenever you can keep a sample preparation method simple, you can improve the results of your chromatography analysis.
So what do we have here in terms of supplies?
We have only a few supplies that are necessary. Here is the Samplique extraction kit, 50 ml vials, and the salt. We have the cleanup dispersive SPE kit, and pipettes, funnel, pH paper, stopwatch, and some standards.
So how many steps are there in the catcher's method?
Well, the method is very simple. There are some variations that come into play depending on the type of food you are analyzing. Agilent has a recommended standard operating procedure, about 8 steps for the catcher's method. I'll take you through the steps now. The first step is to grind up the representative sample, 1 kilogram or so it is consistent. We use a large grinder to prepare the sample I have here. This is the strawberry sample. It is recommended that you use dry ice during the grinding process so as to prevent the loss of more volatile pesticides. After milling, transfer a subsample to a 50 ml tube immediately to avoid losing any analytes and store the rest. You select your kits based on the sample size you plan to use, weigh it to plus minus 0.1 gram, and transfer it into your extraction tube. Next, we do the extraction process. First, we take our 50 ml tube. We're going to add acetonitrile. And shake the tube for 30 seconds. Of course, you can do multiple samples. You don't have to do one at a time. You can fill it up with 3 or 4 samples and shake them at the same time. Now we add our pre-measured packet of magnesium sulfate and sodium chloride to the sample and shake it vigorously for 1 minute. Now we're going to shake it vigorously for 1 minute. It's important to add the salt second after the acetonitrile because adding salt directly to a food sample with a high percentage of water creates an exothermic reaction that can affect your analyte recoveries. That's why it is great that the Samplique catcher's kit have the salt mixture in a separate packet like this. Okay. We want to shake this for 1 full minute. Most fruit and vegetable samples contain between 80 to 95% water, and this step will help to ensure that a phase separation between this water and an organic solvent takes place, so that the pesticides of interest will be in the organic phase.
Almost a minute here, coming up on it.
Now we're going to check the pH. This is a little acidic. Probably add a little bit. This is about 4.7 now. Probably going to add a little bit sodium hydroxide to adjust the pH. This is 5 normal sodium hydroxide. Next, we want to add internal standard. For this purpose, we're going to add 20 microliter of internal standard. The internal standard we're using is triphenyl phosphate. Triphenyl phosphate has the right property to undergo quantitative method for low-fat matrices. After adding internal standard, shake this for 30 seconds. Okay, would you be my timekeeper?
Sure. Go.
You don't have to do this one sample at a time. You can have 4 at a time, so you can shake them all together. Have a great workout.
2, 1, and that's 30.
Perfect. Now we are ready to go through centrifuge. Okay, now we are done with the extraction. We're going to do the dispersive SPE process.